what we're gonna do is play with the world shader here, which is basically a vertex offset, which means that you can move your vertices in real time by the shader, which is kind of cool. So just to demonstrate, I wanted to grab our, trusty friend, time and cosine, for example. Let me just plug those in, and then I just plug them into world position offset. And now as soon as I hit this real-time preview button, you can see that the sphere started animating. And now if we multiply it by a constant, things will get even more fun. Because right now it's like, well, the scale is not that big, so it's not that interesting. Well, let's just crank it up to 5, plug it in here, plug it into world position offset, and there you go. It just offsets your vertices according to their local normals. Well, technically right now it just seems like it's moving because we probably have to multiply it by our world position node, or there's supposed to be a world normal. Yeah, I think that's it. So now when we multiply it by that, we'll be actually transforming, well, offsetting the vertices along their normals. Yeah, you can see this just sort of inflates and deflates. And yeah, that's actually very cool because you can do a lot of stuff with it, either like animate stuff from the shader, so you don't have to do your like ambient animation and keyframe several. Yeah, I hope you see the idea. But the other cool use that we can have for it, for example, I use it for sand, or you can use it for snow or anything. You can actually offset the pixels of your surface where there is like snow, for example. So we're going to do that also right now. And I'm going to stop the preview just so, I don't know, I hope it doesn't get chuggy with the recording and everything. But basically, what we do here is we can either, well, we'll grab our vertex colors because it's a bit more straightforward here. Or you know what? I think we'd better off doing it with vector transform node because we won't have to go back into the editor to preview it. But basically, now I think we're going to keep some of that stuff, like this part, so we can delete the cosine and the time. What we're going to do now is just for everything that has moss projected on top, or for example, if it was snow, we're going to use our dot product to sort of specify which vertices do we want offset. So now as we plug it in, you see that the top part sort of grows. Oh yeah, and I forgot the constant clamp because here was the -1 and it also moved, which is not very good. So hopefully when we plug this constant clamp now, everything should be peachy. Yeah, it sort of moved back. So now, for example, if you want I don't know, the snow on top of your rocks to be like pretty huge, you just set it to 15, and there you go. It sort of grows, and you can adjust that. I mean, technically, you could also vertex paint that stuff, like how much do you want it to grow and everything. So it is pretty amazing what you can do with it. And I think we can just leave it at that for now, just not to overcomplicate stuff. But you can do the exact same thing with your vertex colors. Just grab your vertex color and yeah, multiply it instead of all the vector transform and dot products and stuff. One thing to remember, which is very important, you can't sample pixels for the world position offset, which means you can't have any textures. You can't create a texture mask that you're going to offset your vertices by, because this is done in the vertex shader, and in the vertex shader you don't have pixels. That kind of makes sense because yeah, you sort of transform them one after another, first vertices and then pixels. So you don't sample textures. Yeah, that's it. So you have to get creative sometimes, but that kind of mathematical operations allow you to, get what you want without actually using any kind of textures. So this is very neat. Let me just comment this out as a, I don't know, up offset. That's it. I'll be short this time. Anyway, now there's one probably last thing that I want to show you guys, and this will be world space masking, which is pretty dope as well. And for that, we have our object world position that we used for you remember to offset the UVs as we move our assets around. So let's just grab that, and now it's gonna get kind of funny. Let's just try and clamp it. Well, now we won't really be needing this one, because you see it says world position, but it's an object world position, which basically just gives the coordinates of the center of the object or the pivot. I'm not really sure. And what we need is a per pixel thing. So now we're just going to go ahead and take out this one, which is world position. And now let us finally clamp it. And you'll see something really cool. Let's just plug it in here. Oh, you see, you get a variety of colors, and you know why is that? Because this fella has a lot of vectors in it, a lot of components. It's not only, well, not what we need, and we need right now is just the height for the test. So let's grab a mask component and just check B, which is the Z coordinates, which is the height. Because it would make more sense in a production, and you'll see why. But yeah, there you go. You have your top glowing, which is kind of cool. But the thing is, you see, there's the grid. The grid is 0 in Z, basically, the Z coordinate space. So everything upwards has a positive value, and it just keeps going up, and everything lower is a negative value. And since we clamp it, it says 0, so that's how it would be displayed. And now what we can do to offset this baby is just go ahead and add something. Let's grab a vector here, plug it in here. You're gonna get a little error, but that's okay. Grab a constant, and let's, I don't know, subtract 40. Oh, looks like it moved. Let's put it back to 0. Now let's add 40. You see that we can actually control how the mask goes. Once again, we can't really deny ourselves some fun, so let's grab the sin node or cosine or whatever, plug it in, and just watch it. But it's going to be actually pretty small because it's just -1 to 1. So let's grab a multiply, and we'll see our mask dynamically shift. And I mean, this space that we have here in the material editor is pretty similar to what you have in game, so it's not like it's only here where it's 0. There you go, you're sort of animating your mask. I mean, you can also probably find out the radius of the sphere in in the game unit. So something like 140 will probably cover it all. Well, almost. Yeah, it must be 150 or something. So now we go, oh no, not really. Okay, let's try 180. Yeah, but it's just a little trick to show you. Everyone loves animated stuff, so that's about it. But technically, yeah, you can adjust this. And I mean, if I was making like a real shader with it, I would convert it to parameter and set it to height, or like world space. Well, let's call it, like, for example, what you could use this for is you could use it as a mask to, for example, do objects that are submerged into water or whatever liquid. So after a certain level, they would be displayed differently. So let's just call it water level. And yeah, let's get rid of all the happy animated stuff. And now, just to explain you a bit better, if here's a 0, if we make it a 40 here in our parameter, that means that -40 becomes the 0 now. So we go from 0 to minus 40. That's why when you add stuff, it goes down, and when you subtract stuff, it goes up. Because if we had a 40 here, and we subtract a 40, 40 becomes a 0. So 0 moves up here. That's just the general logic behind it. So yeah, so you wouldn't be just too perplexed by adding values, lowering our water level. But now there we have it. There we have our mask. So at this point, for example, we could take our diffuse map, diffuse map with blended moss, and we can create a constant 3 vector, which would be, well, let's convert it to parameter because it's easier to select colors. Then let's just make it sort of this cyanish kind of color. So, for example, if we're going to get stuff that is underwater, we'll probably want to make it a bit darker and a bit more bluish. Not that saturated for now, at least. But what we're going to do next is we're just going to grab a multiply node. We're going to multiply what we have by this color. And now we're going to grab a linear interpolate again. And let's just plug it in. So yeah, let's grab, I think, this and this and this in that particular order, and see what we get. You see, everything below a certain level is blue now, which is really neat, actually. And once we're going to preview it in the level editor, you're going to just see how awesome this is. But right now, the one thing that we haven't really played much with is the specularity. So what we can do is we can create another parameter, which would be, well, yeah, let's finally name this baby. Okay, how about spec underwater? And in the alpha, we're gonna put spec in, well, let's just call it intensity. And this is a little trick that I like to do often, just to keep, my parameters tightly packed. And this would be spec on the surface. Let's go with over water, just for giggles. Anyway, we should probably make this a bit more orange just to have a little contrast here. And for the spec intensity, let's, I don't know, give this a 4 and this an 8, because we want our underwater, not even 8, like a 16, because we want our underwater stuff to be shinier. So now we have our spec map here, and we will just multiply it by the stuff. So yeah, right now we're going to multiply the underwater side of things, and you can see I'm keeping it logical, and the overwater part is on top and the underwater is at the bottom. But there you go. I think we're going to need a bit more space. That's why let's just our stuff by our intensities. Let me do just that real quick for you guys. Let's actually comment it out. Let's call it water level mask. And let's put it somewhere back here so we can access it from here too. And now we just use this as the alpha. Water into B. So yeah, there you have it. There are two specularity values, and we can probably brighten up the underwater part even more. Okay, so there we go. And now we can finally plug it into our spec and remove this from our emissive because we don't really need it. And this is our diffuse. And now we'll just stop previewing this node that we have. Now for the spec, well, you should be able to see a minor difference, but I guess it just calls for more drastic measures. Let's crank it up all the way to 80. Yeah, one thing that we probably want to fix before that. Let's grab two constants. And yeah, let's make them a parameter. So this is going to be surface gloss, or specular power as it's called in UDK, and this is going to be underwater gloss. And like the average parameter that I found seems to be 13. But for our underwater stuff, we want a way wider highlight because it's supposed to be wet. So let's make it 2. And now let's grab a linear interpolate again. Make sure it's plugged into our water level mask. And then we grab our 2 spec powers, and underwater stuff goes into A and surface stuff goes into B. And now we just plug it into our spec power, and you can see that the underwater stuff now is way shinier, while the surface stuff could use a bit wider highlight. Let's make it a 5 just so we can see something. Okay, even a 4. Yeah, but it has a way less brightness value, so that must be it. Anyway, now we can get rid of our 80 intensity in here and make it like, I don't know, let's try now for too low, 40. A tad too bright, maybe 20, but that's not it. It's just like, yeah, it's specular and everything, but we can go further than that and do something with the additive. Let's just comment this out as glossness. There you go. Here we can just leave it at that. I don't think it's that confusing at this point. You see, when I work, and hopefully when you guys work, try to keep things more or less organized so you know wherever everything is. And yeah, we can just plug that back in, I guess. No idea why it's unplugged actually. Anyway, now we can do to sort of enhance the wet look that we want, because basically what the wet properties of the surface are is that it's way more reflective. It got all the specular highlights. It's a bit darker, and since we're probably going to get this underwater, we want to add a bit of a color tint. But apart from that, the one thing that I want to add would be let me grab the content browser here, and let's just select the UDK game and search for a cube map. We should get something. Let's go with this. So yeah, now we have our cube map, and remember that we used to have a reflection vector that we did just in order for the vertex colors to work with our transform node. Let's just plug the reflection vector in here. So now we're supposed to have it like for a purpose. So technically it should work, and we'll be able to delete it from here. Hopefully. Anyway, now we have a reflection, and we probably just want to have a little parameter to multiply it by. Let's just call it reflection intensity. And let's make it 0.2 because we don't want it to be like a mirror, completely reflective. Now we'll just grab a multiply node from here. And yeah, I accidentally copied this one. So yeah, let me just plug it into here and plug this one here, and then just plug it into emissive. And you see our surface is wet. But that's not really what we want. We want only the underwater part to be wet, which means I messed up. But it's not that bad, which means that technically we can just revert it and multiply our cube map here, which means that everything that's on the surface is going to get multiplied by black, by 0, since we'll revert this stuff. So let's do just that. Let's go and grab a 1 minus and just invert it here. And well, let me drag it all the way to here, just so it would be more obvious why are we reverting it. And then we plug this stuff in and we channel it to emissive, and we stop previewing this node. there you have it. The reflective part is there, and we can, you know, tone down the reflections even more, just so we know there are some reflections. Okay, even more. So it looks kind of wet, you know. And now, you know, the moment of truth. Let's just apply the material and go check this stuff out in the editor window. And you can see you can't really see stuff at this point. Okay, let me just rotate our vector so we would be pointing downwards a bit more, sort of similar to what we used to. And there you go, like -0. Our stuff is wet, but you know what? It seems like the reflection contribution over here is a lot greater. Oh no, we can just do it like this. Then 0.15. You don't see it, guys, but I'm just adding a bit more reflectivity here. I don't know for what reason, but anyway. Because now I'll be able to move stuff without actually interfering with what you see, guys. And now let me just drag it up and down, and you can see that it's sort of masked. I mean, yeah, the wet effect is really crappy. Well, the main point here is to show you guys that you can do that kind of stuff, because in world coordinates, like the offset that you have, so you can have a river or anything, and you just have your stuff, you know, wet under the surface. And I mean, it's not supposed to sort of replace the plane that you'll have for a river, but just to give you an idea that you can also modify this stuff. So I'll try to, you know, drag this in and just play with not even play, but let's animate it. Hell, why not? Let's go to our water level mask and bring our cosine back and bring our time back. And once again, you can always vertex paint the wetness and that kind of stuff. Okay, so let's grab a multiply. Let's just multiply those two. And since our object is very, very huge, let's make it a 180. Why not? We'll get like 360 units of you know, movement. So there you go, and you can see that it. Let me get this out of the way. You can see that our water level is animated, and it actually, you know, affects other objects. So if you create a copy, you know, lower it, you can see that we have our vertex offset for it. Then we have our vertex painting there as well. And we have our wet effect. So it's like a pretty complicated shader. We have our like 100 instructions here. But yeah, I hope this was helpful. I hope you guys enjoyed it, because yeah, it's a lot of stuff to cover, and I know it might be a bit intense, but I really wanted to make it like a one single material, just so you see how much you can put into a single asset. It's just the power of shaders. And yeah, well, see you guys in the next chapters, where we're going to be breaking down some more stuff, which is going to be not that huge. That's the only huge chunk that we have. I promise you guys, the stuff we have up next, we're basically just going to have some more practical examples that are going to be just, you know, singular. We won't be doing 10 things in a single shader. We're just going to concentrate on one thing per one little video per shader. So yeah, thanks for, you know, tuning in, and see you in the next chapter.